In section 11.4, we're looking at circumference and arc length. So looking at some circle stuff today. First of all, what is circumference? Circumference is the distance around a circle. It's like the perimeter of a circle. Okay, so distance around a circle. Now, you know that this pi, this number, and should be a button on your calculator for pi. It was discovered, and really the way it was discovered is the ratio of the circumference to diameter of a circle, of any circle. Pi is equal to circumference, which again we're saying is the distance around a circle, divided by its diameter. And that's how we came up with pi. Well, if you think about it, to get circumference alone, you would multiply by diameter. Circumference of a circle is equal to pi times diameter. And that version is right here. Or you can say circumference is 2 times pi times radius. Now, why are these the same formula? Well, isn't 2 times radius the same as diameter? Okay, so circumference is either 2 pi r, 2 times pi times radius, or pi times d, pi times diameter. Again, same formula. Now, to be as accurate as possible, you should always use a pi button on your calculator. If you have to approximate, of course, you can do 3.14. But pi is an irrational number. It goes on forever. Decimal, it never ends or repeats. So keep in mind you should be accurate as possible. Another thing to be aware of and be able to use today is that if you think about a wheel on a car or a wheel on a bike, what is one revolution of that wheel on that car or that bike? Well, if you think about a revolution, it'd be like going around once, right? A revolution is going around once. Now, if this was a moving tire and suddenly it starts rolling, let's say we're going out to the right. Okay, let's say this starts rolling. Well, now all of this is touching the ground. It keeps going to the right. All of this is touching the ground. And one revolution ends up coming back to the place where I started. One revolution of a wheel is the same as a circumference, the same as the distance around, same as 2 pi r or pi d. So keep that in mind if you talk about a revolution of a wheel. You're just talking about going around the wheel once, which is the same as a circumference. Doing some quick examples here. Find the circumference of a circle. Let's say the radius is 15 inches. Well, if I'm given the radius, I might as well use 2 pi r. Since that's what I have, so I'm doing 2 times pi times that radius of 15. Again, use the pi button on the calculator, and if you want, you could even do 2 times 15 and think, well, the diameter is 30. So I'm doing 30 pi. Now, that's actually an exact answer if you left it that way. Because I don't have any crazy decimal, I didn't round. And then my label, since circumference is a distance, would just be inches. But if I go on the calculator and I actually type in 30 pi, 30 times pi, I get 94 points, and I'll do 2 decimal places, 0.25, again, inches. This is approximate, I had to round. Next example, find the circumference of a circle with a diameter, 10 centimeters. Well, if I'm given the diameter, I might as well use pi d, right? So circumference is pi times diameter. Diameter is 10. Might be better to write 10 pi instead of pi times 10. Again, this would be an exact answer. If I said 10 pi centimeters, there's my circumference, my distance around. But of course, I can do 10 times pi, actually. Oh, which I guess would be 31.42 centimeters as a rounded answer. Next example, a little bit trickier here, solving for an unknown. Find the radius of a circle with a circumference of 36 pi feet. Wait, I know the circumference, it's 36 pi feet. I need the radius. So if I need the radius, I should use this formula, right? Circumference is 2 times pi times that radius I need to find. Circumference is 36 pi. So instead of c, I'm putting 36 pi because I know that's the circumference. And that equals 2 times pi times unknown radius. Now, if you want to get radius alone or solve for it, I need to divide by both 2 and pi because it's 2 times pi times radius. These are all being multiplied. If I divide by 2 and divide by pi, these both cancel out. Here I'll divide by 2 and divide by pi. Now, I get lucky here because pi's cancel. Pi divided by pi is just gone on this side. If that does not happen, and you have to do this on the calculator, make sure you actually divide by 2 and divide by pi. Okay, make sure you hit divide both times. But in this case, they cancel out. And 36 divided by 2 is just 18. Now 18 equals the radius, right? So I should put a label though. The radius is 18 feet. It looks like circumference was feet. Radius would be feet as well. Okay? So basic circumference stuff. Talking about those revolutions of a wheel. Let's look at some examples here. The diameter, so the entire distance across a bicycle tire is 30 inches. To the nearest foot, inches, we're going to need feet eventually. How far does the tire travel when it makes 100 revolutions? Okay, wait, now a revolution is the same as a circumference, right? So this is 100 circumferences. So I need to know what's one circumference. I know the diameter is 30 inches. What is one circumference of this wheel? Because the circumference is the same as one revolution. Alright, circumference could be 2 pi r or pi d. I know the diameter is 30, so why don't I do pi times diameter? So pi times 30, or 30 pi. So that's one revolution, that's one circumference. Maybe I'll do this as a decimal. 30 times pi is about 94.25, rounding. The only problem is that the diameter was in inches. So this is also in inches for that one revolution or one circumference. But it does say nearest foot. So let's convert here. Now I know there are 12 inches in a foot. I want inches to go away, so I'm putting that on bottom so that they cancel. Let's see. Inches will cancel now, top and bottom. There are 12 inches in 1 foot. So I'm doing 94.25 divided by 12. 94.25 inches is actually 7.85 feet approximately. Oh, okay, so this is one revolution or one circumference is 7.85 feet. But we're doing 100 revolutions, right? So 7.85 feet times 100 revolutions. Really, because this is 7.85 feet per one revolution, right? We'd cross that off. So multiply by 100, I'm looking at 785 feet. They said I could do nearest foot, 785.39, so about 785 feet. Okay, so keeping in mind a revolution is the same as the circumference. Found the circumference of that wheel and multiplied by 100 because I'm doing 100 revolutions. Alright, next example here, a car tire has a diameter of 28 inches. How many revolutions does the tire make when traveling 500 feet? How many revolutions? So we don't know how many circumferences, right? Revolution is the same as a circumference. How many we're doing, but we know we travel 500 feet. Well, I'm going to need to know what the circumference is. So what is the circumference of this car tire? Diameter was 28 inches. Circumference is pi times d. So pi times 28, or 28 pi. And 28 times pi is about 87.96, and that's in inches. Okay, so one circumference, or one revolution, remember a circumference is the same as a revolution, is the same as 87.96 inches. Oh, okay. But we're traveling 500 feet. You know what? This time I'm going to go feet to inches. So I want to know how many inches I'm traveling. And I want feet to cancel, so I put that on bottom. Multiply by conversion. I know that there are 12 inches in 1 foot. This is a fraction that equals 1. Feet will cancel. 500 times 12. Okay, there are 6,000 inches then in this distance that we're traveling. So we're going 6,000 inches, but we know there are 87.96 inches in 1 revolution. This is a fraction equal to 1 because these are equivalent, right? 1 revolution, 1 circumference is 87.96 inches. So I'm going to take the number of inches I'm going, which was 500 feet, right? 6,000 inches. See how many revolutions I'm doing. Now I know that 1 revolution is the same as 87.96 inches, which is why I can multiply by that. And inches will cancel out for me. So I'm taking my 6,000, I'm dividing by the 87.96 inches that were in 1 revolution, and I'm ending up with 68.21 revolutions. Okay, so here I define that circumference, that revolution distance, take my distance I converted to like units, and figure out how many revolutions it would take to cover that distance. Alright, so we're good with the basic circumference stuff and the basic revolutions info. Now, I'm going to move on to arc length today. Now, when we talk about arc length, we literally are saying what's the length of a portion of the outside arc of a circle. Okay, so we need to start out and say what would the full arc length of an entire circle be? That would mean this full distance around that circle. We just gave a name to that. What is the full distance around a circle called? That would be the whole circumference. But generally, when we talk about arc length, we look at only a portion of the total circle. So like here, the length of arc EG. If I wanted the length of this arc, this is a part of the total circumference. But how much? And my question is, like, what fraction of the circle is that arc? Like, what fraction could I put of circle arc? If this is a 90-degree central angle, I'm looking at 90 degrees out of 360. Right? I mean, 90 degrees out of a full circle, which is 360. Doesn't that reduce to 1/4? Because aren't there 4 90-degree angles in a full circle? So if I wanted the length of... That looked messy, sorry. If I wanted the length of arc EG, if I knew the whole circumference, I would actually want 1/4 of that. It's only 1/4 of the circle. What if here I wanted the portion of the circle that arc CKJ is? That's this entire arc. How much of the circle's circumference is that? Well, I think right away you're telling me that's half of the circle, isn't it? Because it's a semicircle. We're looking at 180 degrees out of 360. We're looking at half of the circle. Circle O in this case. And finally, what about over here, arc EF? What portion of the circle is this arc? Well, wait, this is 120 degrees. How many 120 degree angles are there in a 360 degree circle? That reduces to 1/3, right? Really, this is 1/3 of the circle's whole circumference, 1/3 of the circle's whole arc. So my question is, how can we generalize to any random angle measure or arc size? Well, it's a portion of the circumference, right? I know I was just saying 1/4 because it's 90 out of 360. I know I was just saying 1/2 because it's 180 out of 360, or 1/3 because it's 120 out of 360, but you take whatever the angle measure is, or whatever the measure of the arc is, and it's always going to be out of 360. Because you know the whole circle is 360 degrees, and you're looking at, like here, 90 degrees out of 360, or 180 degrees out of 360, or 120 degrees out of 360. So if you had some random angle measure like 14 degrees, it's still out of 360. And it's a portion of the total circumference. Because if we're talking about the length of this, it's a length out of the whole circumference of the circle. Because remember, the full arc length is the circumference. So let's create this formula here. If we are looking for the length of an arc length is really just a portion of the circumference of a circle. So if you want the arc length of whatever arc AB might be, you take its measure out of 360. Again, what portion of the total circle are we looking at? That's what this gives you. And then multiply by the circumference. Now, you can use 2 pi r or pi d, of course. Like, you could just put c for circumference. You could use 2 pi r there. You can use pi d there. Depends if you have radius or diameter, or if you have the circumference. But the length of an arc is just a part of the total circle's distance around. And the part of the circle is the arc out of 360. Like back here, it was, this would be 1/4 of the circumference. This would be half of the circumference. Whatever it is would be the angle out of 360 of the total circumference. Again, use 2 pi r or pi d. So, Find the length of each arc. If I want the length of this highlighted arc here, I'm thinking, all right, the length of that arc is just a piece of the total circumference. It's just a piece of the total circumference. So AL for arc length. What portion? Well, I'm looking at a 45-degree arc out of 360 degrees. So that's my portion, right? The measure of the arc that I'm looking for, 45 degrees, out of 360. Now that's a piece of the total circumference. Now for circumference, I can put, just C. Or I can put 2 pi r, or I can put pi d. I know the radius of this circle is 9. I might as well use 2 times pi times the radius of 9. And I'm just going to go to the calculator. I'm going to do 45 divided by 360 times 2 times pi times 9. And I get that the arc length equals 7.07. The radius was in inches. The length of this arc would also be in inches. Now, if you think about, is that reasonable? It does look like the radius is a little bit longer than what this arc would be. So it makes sense. The radius was 9. The arc was 7.07 inches. That seems reasonable. Okay. Again, I looked at how much of the circle was I dealing with. I was only dealing with 45 degrees out of the whole circumference, which would be, or the whole circle, which is 360. And that's how much of the circumference I needed, which would be 2 pi r, or 9 here. Let's try this again. All right. Notice this is the arc I want. It's highlighted here. Now, arc length, I need the piece of the total circle. Now, a total circle is 360 degrees. I'm not doing all 360, but I am doing, oh, you know what? I got to be careful here. This is 120 degrees. This central angle here, which means this arc out here is 120. But the arc I want is everything else. So really, I have to do like 360 minus 120, right? The whole circle minus this arc. So the arc I need is 240 degrees out of 360. And that's the piece of the total circumference that I want. Now circumference could be 2 pi r or pi d. I know the radius is 15 here, so I'm going to do 2 pi r again. 2 times pi times the radius of 15. What is the arc length? I do 240 divided by 360 times 2 times pi times 15. And my arc length then is 62.83. And the label would be the same label as the distance for the radius, which was centimeters. Now, does that make sense? If this was 15, the radius was length 15, this would be 62.83. And that seems reasonable because that's a lot of circle I'm dealing with there. Radius 15. Okay. That looks good. I'm going to leave this last example for you to do coming into class tomorrow. Again, I want the arc length of the highlighted arc. You can tell the central angle is 85 degrees. So that arc is 85. Out of the total circle, and the radius is 12 feet. Now, the answer you get, I would say, if radius is 12, it looks like this distance would only maybe be slightly greater than 12, so maybe a little bigger than 12 there. Not like too much, I would say less than 20, I would think, but yeah, check that your answer seems reasonable. This was 12, that shouldn't be too much more than that. Bring the answer to class tomorrow. Talking about circumference and arc length today.